bit of this in our last notes. I felt that by talking about the other form of a plus bx, it was causing a little bit more confusion than anything. So we're going to keep it at y equals mx plus b. M is known as many different things. It's the rate of change, the growth factor, the slope, the change in y over the change in x, delta y over delta x. B is our initial value, our zeroth term, or our y-intercept. So let's get a little bit of practice here writing some equations. If I get a volunteer to help us write these ones right in here. Did you? Y equals 38 plus 7x, or 7x plus 38. Okay. We have our initial value, and then we have the slope, which gets our x next to it. Let's write it in y equals mx plus b form on the next one. Can I get a different volunteer for the second one? Gigi? Well, let's do it with mx plus b. Slope. Negative 15x plus 57. So the initial value does not have an x next to it, whereas the slope has the x with it. Our next one? Yes. Minus 6. We can also say something like plus negative 6 if you really feel like you want to do it that way. We can also do it that way. Notice that with the slope, we have the x right next to it in that equation. And our next one, our last one of this example, negative 5x. And yeah, we could just leave it like that. If you want to, you can play plus 0, but typically we just leave it as y equals negative 5x. Now this is math that, again, you should, I'm trying to do my best to review this. It's math that you should be coming in. And again, why are you learning this? We're going to be making transitions and connections to financial math. How does, when you put money into your bank account, how does that affect, and why is that a linear equation? That's what we're going to be making the connection to. All right, we talked a little bit about this yesterday in terms of tables. We're going to practice now completing the table 3 days ago. Completing the table as well as finding the equation and slope. All right, so can someone tell me what it would go here? Juju again? For 0. 135. And how did you get that it was 135? So it's going bound by minus 15. So then that means if I go in the other direction, I'm going to add 15 if I'm going from bottom to up. Or I can just think of this as, once again, I got to go down by 15, so I'm adding 15 to that. So can I get somebody else? What would be in box 3? 90. 75 is already right here. Did you say 75? Did you say 75? Oh, okay. Well, 90 would be that next one right in there. Oh, you said that. 85, 95, 15s. So what's the slope? Jimmy, what's the slope? It's written right there. It's on the screen. We just wrote it down. It's how much it's changing by. It is negative 15. Now, it's negative 15 because this is increasing by 1. So the slope is actually negative 15 divided by 1. So be careful to make sure that this number right here on the table on the x's is going up by 1s, because if it's not going up by 1s, that's not the slope by what's going on the other side. Okay. Yeah. Ernesto?
Okay, can I just show him something?
Yeah. You can go. We got another example. Or you wanna take over?
No, you're fine. So what he's saying is this one is negative 15, right? When you go down, but you have to also think about what's changing on this side. Because if this was a 2, then you would have to divide this by that, and the number would change. So be careful. Make sure that you're also checking this side when you're determining slope. Because right now, 15, right? If you do divide it by 1, it's still going to be negative 15, right? But if this was a 2 and that was a 10, then you would do 10 divided by 2, which would be 5, right? So just be careful.
And we're going to do that on the next example right there.
Okay?
Good. Jahira, what's the initial value? What's our initial value? Initial value is when x is 0, right?
When you're at 0.
What's our initial value?
What's the number at 0?
You want to say it?
Say it aloud.
No, the number next to the 0. Yes.
Good job.
I was looking for 135.
That's what you start with at 0.
And our equation would therefore be? Perfect. Y equals negative 15x plus 135. I think the thickness is here. Let me go to thickness 3. All right, let's do one more example, and then I'm going to give you some time in class to practice this on your own. How much is the y value changing by? Yeah. That. You can write it this way, yes. Either way, I'm accepting. Yes. There we go. So this one is changing by, is it minus or plus? Minus. It's going to the left of our number chart. So it's from minus 19 to minus 26. So this is going down by 7. So what does this number have to have? They get it. Look at that. No, you're responsible to get it back. Come on, let's get it. It's going to be negative 12. And the reason, so we got to do a little bit. So we're adding 7. We're just going to the other direction of the number line, which would make this next number what? Negative 33. I know we don't have. I'm loving the attempts, by the way, that you're not trying to type it into your, mental math is important. These numbers can be done mentally, and we want to practice. Even if you're getting it wrong, thank you for saying those numbers, because we're going to get better at mental math. All right, this is tricky. What is our slope? Slope. Close. How much is this? Our x is going up by? By 2. Close. This is what Miss Patterson was trying to say, and when she was noting this. So I'm hearing a lot of negative 7, but it's not just negative 7. Because remember, we want to be careful. Negative 7 over 2. Yes. Oh, let's get that. Whoever phone that is, if you can just get it over and turn it off. It happens. So whatever number, yeah. If it's not the number 1, then we want to divide by that. What's my initial value, Jahira? There we go, negative 12. And our equation is therefore y equals? Somebody? Our slope, remember our slope? Negative 7 over 2. We plot the x, minus 12. So the next one is about using a word problem. We're going to spend about 5 more minutes just on this one, and then you'll have the rest of class time. That's all the time. I just want to make sure I get through both parts. parts of our lesson today. So, the goal is to connect this to how our money works in real life. And the way our money works in real life when talking about linear equation is how money works in our checking account. So when you put money in your checking account and you add $5 every month, or you add and you keep adding the same amount, that's a linear model. It's going to be a linear equation. Versus when we put our money into savings or we invest our money, that's going to be a different type of equation that we'll talk about next. So in this problem, Malcolm's checking account has a minimum balance of $1,500 and charges a $14 fee each month the account is below that minimum. After buying tickets, Malcolm's balance is $1,357. So will he have a fee? So this is how the real world works. You put money in your account. If the money in your account falls below, the bank charges you fees. In this case, they're charging you how much? $14. And the key thing is each month. Each month, they are charging us $14. So that $14 is going to represent our what in the equation. Remember, we have our y equals mx plus b. What does that $14 going to represent in this problem? Is that our initial? It's our rate of change. Is it positive or negative? Negative. Fees are negative. Okay? Fees are negative, so that means our slope is going to be negative 14. Okay? How much do we currently have in our account? $1,357. And that's at time what? When x is what? When x is 0. Yeah. All right. So this right here would be, this represents months, and this is our account, this is our balance in our account. Now, and this is how the real world works, we don't buy anything else. Because we are below the minimum, the bank's going to keep charging us fees. Fees are terrible, and there's a lot of other types of fees. So this is just one type of fee called a checking fee, a minimum balance fee. As students, we want you to open up bank accounts that have no fees. You should have a student banking account that has no minimum balance, doesn't have a monthly checking savings balance, and we hope that we open you that. So now we're gonna just go through the months. 1, 2, 3, 4. How much does he have after month 1? Perfect. Month 2. Now we got that by subtracting $14. 1,300 in. Close. 29. Someone with the, I know you're cheating over there. Next one, 1,300. 1,300 in. 15. Perfect. Finally, 1,300 and 1. So after 4 months of not buying anything, Malcolm's account went from $1,357 to $1,301. This is what banks do, and it happen months after months after months, years after years. There are some people out there that don't pay attention, and they get charged fees for many, many, many months, many, many, many years. This might be also some of these different, like a subscription. Some of you know there's all the videos. You have your random subscription that you're not even using, and it just keeps adding and adding and adding to it. So what's my initial value?
Initial value is always found at what? Which number?
Yes.
0.
When x is 0. So I heard 1,357. My slope is going to be negative 14, and that's because the x is going up by 1. Also because we just found it directly from our equation, right? So minus 14. And therefore my equation is, can I get somebody that's maybe hasn't? Right here, yes. 1,000, y equals? Find when x is 12, what does this mean? What do I do? What am I going to do if I want to find out how much is in a checking account when x is 12? What am I? Not add 12. Not multiply by 12. Not divide by 12. No, think about it. Here we have an equation. I want to find y when x is 12. What do I do with the x? Okay, be a little bit more clear. You're right there. We're going to plug, also known as plug in. And as Juju said, we're going to multiply by the negative 14. So we're going to do y equals negative 14 times 12 plus 1357. And this, your computers, you should be able to do some quick math onto your computers. You can type it in a search bar. It should be able to do that type of math onto here. Do I got anybody that has the answer? What's the whole answer? 1,000 and what? 1,189. And what does that number represent, somebody? It represents how much? It represents Malcolm has $1,189 from when? In 12 months, also known as? 12 months is also known as a year. So after a year of just letting his money sit there, not doing anything, he went from $1,357 to $1,189 just because of fees and letting those fees hit him. And I have a lot of family and friends, not just this type of fees, but other types of fees, that they just lose money to fees and fees and fees and fees. It's only $14, but it adds up, right? Yeah. Sorry, let me put $2. There we go. All right. I want you to practice it. And that's what we're doing for the remainder of class.